Hello everyone, I'm Francisco and today I will present our SIGCOMM demo, the GhostTwin, towards live digital twins via smart NIC network emulation. So, the network infrastructures are becoming more and more complex, having new computing units like programmable switches and smart NICs. They are also becoming bigger and bigger as the number of servers and switches in the data centers increases. Even with this increasing in the complexity and the size, they are expected to deliver characteristics like high throughput, low latency for application, reliability, and adaptability to diverse network conditions. Tasks like network testing and the deployment of new network functionalities are not trivial, as they can cause some problems and even break the network operation. In this context, the digital twins emerged as promising strategy to replicate the physical topology, creating digital replicas, and then perform these network testing and deployment of functionalities before the real-world deployment. Digital twins enable to simulate outcomes in the digital replica, see how the network behaves on these outcomes, and perform network validation and improve the overall network readability. Wherever create these digital replicas are also not a trivial task, as they need to collecting constantly the network state, usually more than traditional network telemetry systems, and this information collection can increase the overhead in the physical topology. Also, in the digital replica side, we need to have high fidelity twins representation that can really replicate the physical network topology behavior and accurately emulate the behavior of the live network. This includes also the control logic, the failure propagation, and the traffic load interactions. To address all of these challenges in this work, we propose the GhostTwin, the first open source proof of concept of a live digital twin that can replicate the state of a physical network infrastructure in a network emulated infrastructure. GhostTwin are based on hardware-based network emulation on SmartNet and frequently collect data from the physical infrastructure to deploy the same states in the digital replica. Our architecture is composed of three main components. One is the GhostTwin agent that orchestrates the information collection and the state update. In the switch sides, we have the GhostTwin state monitoring that monitor all traffic passing through the switch and also coordinate the information collection. And in the replica side, we have this GhostTwin state control that will constantly update the current state of the physical network in the emulated network. In our demonstration, we show one setup composed by two switches with two servers connected, sending traffic between each other and collecting this information using our GhostTwin agent and replicating the same state in the emulated network. Next, we will present a brief demonstration about what will be presented in our SIGCOMM demo.
Okay, so let's start the GhostTwin demonstration. The first step is to set up the emulated topology to match the real-world topology. At this point, we have two switches, and they are connected by a link with a bandwidth of 10 gigabytes. We can then run the topology as it matches the real world, and we can then send some traffic through it. Let's say we want to send 1.2 gigabytes of traffic, and it is sending the 1.2 gigabytes via T-Rex here. And when the emulated topology finish setting up, we will receive the same 1.2 gigabytes of traffic. As we can see here, we are receiving the same amount of traffic. Then, in the real world topology, we can set up some traffic exchange. Let's say we want to send 100 megabytes of traffic. We are sending it here. Then we can monitor the interface that is sending the real world traffic and copy it to the emulated topology. We can do that by running the monitoring script. It is getting that the interface throughput is 100 megabytes and is copying it to the emulated network. And we can see here that the T-Rex is receiving the same amount, 100 megabytes of data. Then we can try with different amounts. Let's say now the interface will send 500 megabytes of traffic. The monitoring script is getting the same amount, 500 megabytes. And the T-Rex now is receiving the same amount, meaning that the emulated network copied the state of the real world topology.
Thanks for your attention, and if you want to know more about how to use GhostTwin, please check out our GitHub repository.